So last time we met, we talked about long division, right? So let's go ahead and do long division on this problem so we can refresh our memory about long division, figure that stuff out. You ready? How do we set it up? Where does the divisor go? On the outside, right? So x plus 1 is on the outside. And the dividend goes on the inside, right? Underneath the division sign. 3x to the fourth plus x to the third minus 2x squared plus 2x minus 5. You okay with that? Okay, remember, we're just looking at first terms here. What's 3x to the fourth divided by x? 3x to the third, right? Where does it go? Above the x to the third, so 3x to the third. Now what action do we take? Multiplication, right? 3x to the third times x. 3x to the fourth. 3x to the third times 1. 3x to the third. And now, subtract or add the opposite, right? 3x to the fourth and a negative 3x to the fourth. Yeah, that's 0, so that's what it should be, right? X to the third and a negative 3x to the third. Negative 2x to the third. I just brought the rest down, right? Now we start all over again. Negative 2x to the third divided by x. Negative 2x squared, right? Good. So negative 2x squared. So negative 2x squared times x. Negative 2x to the third. Negative 2x squared times 1. Negative 2x squared, okay? If I change my signs and combine, add, I get, is that okay? Okay, so I just bring down my next stuff, right? Because that's 0 and so is that. Okay, so now start all over, beginning terms, 2x divided by x. Plus 2, where does that go? Okay, plus 2. 2 times x, 2x. 2 times 1, 2. And then change the signs and add. That's 0 and that is negative 7. So my answer is 3x cubed minus 2x squared plus 2 plus negative 7 over x plus 1. You okay with that? Now, wouldn't it be nice if there was a shorter way? Oh, yeah, there is. I didn't teach it to you first because it doesn't always work. Okay? It doesn't always work. And first things first, I want to make sure you know when it does work and when it doesn't. Okay? This is a problem we did yesterday. This problem would not work with synthetic division. Here's a problem we did yesterday. This problem would not work with synthetic division. So what do these two have in common that this one doesn't have in common? My divisor, right? Because I've got a x to the third, x to the fourth, x to the fourth, so it can't be anything about the dividend. It's the divisor. It can't, okay? In fact, it's not just that it has 3 terms, it has an x squared term. If I'm doing synthetic division, my divisor can only be an x term. That's the highest exponent, is just x. X to the first, basically. Okay? It could be 2x plus 1. That's okay. But it can't have a squared or a cubed or a third or a fourth or anything like that. Okay? Only like this. So I'd like to do this problem again for you. I'm going to fold my paper carefully. And I would like to do this problem again for you, but this time with synthetic division. You ready? Synthetic division, even visually, looks easier. Okay? It looks easier because we don't deal with exponents anymore. All we deal with is coefficients. And what does coefficient mean? Yeah, the number in front of the variable, right? Okay? So let's write the coefficients out of my divisor. Excuse me, my dividend. What's the coefficients of my dividend? 3, 1, -2, 2, and -5. Then I write my division sign. Yes, I know it's upside down. That's how we do it. It's okay. And then I have to write my divisor. Okay? The way that I get my divisor is I take what my actual divisor is, and I set it equal to 0. Guys, is that something I can do in my head? If I looked at this, could you tell me that -1 is the thing that has to go out here? I hope so, right? Maybe you can't. So if you can't, then I need to see that work over there. But it's very possible for you to know. What's an easy way to think about this that's not always true? It's just the opposite of that, right? Because if it's a 2x plus 1, it's not just going to be the opposite. We'd have to actually solve that to set it equal to 0, right? Okay? But for sure, take the divisor, set it equal to 0. That's the number that goes outside. Okay? I promise you right now, I promise I'm going to try to go slow. It's really, really hard to go slow on this. Are you ready? Whatever the first number is, bring it down. Whatever it is, bring it down. Now, multiply. -3, write it right there. Add. Multiply. Write it right there. Add. Multiply. Write it right there. Add. Multiply. Write it right there. Add. I forgot to draw something earlier. Can you please forgive me? Underneath my last term, I gotta draw that. Do those numbers look familiar at all? So now I gotta figure out how to get from here to the answer. Okay? This box, guess what that box is for? Your remainder. Okay? That means the term right next to it is the constant, and the term right next to it is the x term, and the term right next to it is the x squared term, and the term right next to it is the x cubed term. So when I write my answer, I have 3x cubed minus 2x squared plus 0x. Do I need to write that? Nah, I can if I want to, but I don't have to. And once again reminding you, that's exactly the same answer we got before when we did long division. It just took us this much room instead of this much room. Okay? Another reason people like this, the long division, better is that it's very, very transparent what's going on. Right? You know I'm dividing this term by this term. I'm multiplying these things, combining. I can still see all my x terms, my x squared terms, all my x cubed terms. To some people, this just looks like a trick. And it's not really a trick so much as it is a shortcut. Okay? But like I said earlier, it doesn't work every time. It only works when your divisor is x plus something, or 2x plus something, or x minus 3, or 3x minus 3, or something like that, right? Questions? Shall I do another one? Okay. Negative x to the third plus 4x squared plus 9 divided by x minus 3. Who wants to start? Ask me. Yeah, you just made me very happy. Okay? What she was saying is, like how for the long division you have to have a cubed and a squared and an x to the first. Do we have to do that in synthetic division too? Absolutely. Absolutely. Okay? So when we go to write our coefficients, what are we going to write? -1, 4, 0, 9. I'm very proud of you. Draw our division sign and our remainder sign, or line, or whatever you want to call it. What goes out here? 3. I'll try to go slow again. You ready? Bring it down. -1. Multiply. Write it right here. Add. Multiply. Write it right here. Add. Multiply. Write it right here. Add. What's the 18? The remainder. So this term is the constant. This term is the x term. This term is the x squared. So what is my answer? Good. Can I tell you what they tried to tell me earlier? They said, well, if it's just 18 over 3, why can't we just say 6? Because when they wrote the remainder, they just wrote 18 over 3. It's kind of close, right? They're getting the fact that it's the remainder divided over what we started with, except did we really start with 3? We didn't, right? We started with x minus 3. You okay with that? Okay. Another? No? Please, I'll do one more. I'll do one more. X to the 4th plus 4x to the 3rd plus 16x minus 35 divided by x plus 5. Oh, let me show you what somebody said to me earlier. Let me see if I can get both of these examples up real quick. Here's the 2 examples we've already done. Let me zoom out a little bit. Here's the 2 examples we've already done, right? Someone said to me, okay, in this problem we started with 3x to the 4th, and we got an answer that was x to the 3rd. Here we started with an x to the 3rd, and I got an answer that was x squared. Is the answer going to always be one exponent less than the problem? And I said, I have a tear running down my face because I'm so proud that you saw that. Does it make sense that if we start with an x to the 4th and I'm dividing by an x, then my answer will be one exponent less than the problem I started with? So, that's something to keep in mind. Because some people forget to draw the box. Shoot, I almost forgot to draw the box the first time, right? And they say that's the constant, that's the x term, the x term, x squared, x cubed, x to the 4th. If I started with an x to the 4th, my answer can't be an x to the 4th because I've divided out part. You okay with that? Okay, so that's just something to keep in mind. More of just like a hint or a reminder when we're writing our answer. Okay? Whoa, wrong way. All right, so somebody set it up for me. 1. Okay. You sure? Good. Oh, thank you, remainder box. Good call. Now, Like, is it literally important that I draw it first? No, I just don't want you to forget it. Okay? All right, bring it down. Multiply. Add. Multiply. Add. Multiply. Add. Multiply. Add. So what's the answer? Remainder, constant, x term, x squared, x cubed. X cubed, good, plus 5x minus 9 plus very, very good. Questions? We good? Ask me if you need help.